Let's solve some quadratic equations with square roots today. Now, typically when you don't have a middle term, like there's no 5x or something, stuck in here, you can often solve these with a simple square root on both sides. So let's not forget what it means to solve an equation. It's simply what squared would possibly be 9 here. Of course, one of the answers is 3, but did you know there's a second answer? Well, let's show our work here. We're square root on both sides. X equals, and there's two answers, not only 3, but also -3. So we put plus or minus 3 because -3 times -3 would also be +9. So two solutions on that one. Now on the right side, we've got a second equation, and when we solve equations, we always do our order of operations in reverse. So is there something we can add or subtract out of there to get x squared by itself? And there is, of course. There we can subtract 2 on both sides and get x squared all by itself, because that is the goal here, is to get x squared by itself, and then you square root both sides, and you get x equals 5. But don't forget, we have to insert that plus or minus because we get two answers. I have several examples lined up, and each one will show you something new. So let's look at this first one here. Notice that we're trying to do order of operations in reverse. Can we add or subtract something out of there? And we cannot add 2 because that 2 is stuck inside this parenthesis. So we really need to get rid of this square first. I always like to think of equation solving as getting rid of things so that our x can be all by itself. So let's square root both sides right at the beginning here. And on the right side, we have to keep track of two answers at this point. We have plus or minus 3. And on the left side, we get x minus 2. You see the square root and the square, they are called inverse operations. They undo one another, and it just leaves the thing that is in that parenthesis that was under the radical to begin with before we squared it, and we get x minus 2. We can now add 2 on both sides. And this is looking a little strange, isn't it? Plus or minus 3 and positive 2. So here's the way I want to write it. I'm going to write x equals 2 plus or minus 3. Now, we can simplify this further because this branches into two options, 2 plus 3 and 2 minus 3. And of course, both of those answers we can work out to nice integers. So x equals 5 or -1. There's two answers to that equation. Now on the right side, this problem is very similar. It has a little twist in it. So we are going to square root both sides, and we get x plus 1 equals plus or minus. Now this is not a perfect square this time. So we'll just keep a radical there, like radical 5, and then we subtract 1 because our goal is to get x all by itself. X equals -1 plus or minus radical 5. And just leave it like that. It's a combination of an integer component as well as an irrational component, which is that radical. Okay, we've got another example here where we're introducing yet another thing. This time we have the 3 on the outside. Now remember, equation solving is order of operations in reverse. So is there something we can add or subtract out of there? No. Is there something we can multiply or divide out of there? Indeed there is. We can divide both sides by 3, and that will cancel the 3, leaving x minus 1 squared. So, but whatever you do to one side, you simply do to the other, and you get all of that equal to 4. Not plus or minus 4, because we haven't square rooted anything yet. But we will do that now. Let's square root both sides, and we get x minus 1 equals plus or minus 2. The square root of 4 is plain old 2. We add 1 on both sides, and we get x is 1 plus 2 and 1 minus 2. So we branch that up. 1 plus 2, 1 minus 2. So the answers are x equals 3 or -1. All right, now on the right side of your screen, you see a new example. Can we add or subtract out of there? We cannot subtract 3 because that's inside that parenthesis. Can we divide by 2? No, that's also inside the parenthesis. So let's square root right from the beginning so that we cancel this square, and we're left with 2x plus 3 equals, and then we're going to square root the right side. That's plus or minus square root of 10. Now, let's solve for x. Let's get x by itself. We have to keep track of plus or minus. Radical 10 is the only little trick here. So we'll minus 3 on both sides. So 2x equals -3 plus or minus radical 10. We then divide by 2. divide by 2, and of course negative 3 doesn't divide by 2, and there's no coefficient in front of the radical 10 anyway. So x equals negative 3 plus or minus radical 10 all over 2 is a great way to write the answer. If you needed to figure out the decimal, you carefully plug both of those answers into your calculator. All right, I put a little bit of everything in here. I get questions on problems like this all the time. So we need to do our order of operations in reverse. So we're going to try to add or subtract something out of there first. What can we add or subtract out of there to get x one step closer to being all by itself? Well, yeah, this positive 1. We can subtract 1 on both sides, and we get 18 on the right side. 3 times the quantity, x minus 4, that quantity squared. All right, we now can divide by 3 on both sides, and we get x minus 4, the quantity squared, equals 6. Now what do? Well, of course, we square root both sides, and out pops plus or minus radical 6, and we have x minus 4 left over on the left side. We simply add 4 on both sides, and we get x equals 4 plus or minus the square root of 6, and that can't be simplified, so that is simply our answer. All right, this is the last problem today, and you might be thinking, oh my goodness, this looks completely different. We have a middle term this time, so how could we possibly use a square root? Well, if you are good at factoring, you recognize that the left side is 2x plus 3 times itself. It is a binomial squared. So we could rewrite it like that first, and then square root both sides. And you get 2x plus 3 equals plus or minus radical 6. We then subtract 3 on both sides, so we get 2x equals negative 3 plus or minus radical 6. Divide by 2, and we get our two answers, negative 3 plus or minus the square root of 6 all over 2. So at the beginning, I had to factor, and that allowed me to use a square root. I hope you found this useful for using square roots on both sides of the equation, and until next time.